All right, let's do this example at the bottom. Sorry about the break in the action there. So we have Ted, and he's trying to find the best possible route to school. He has 3 choices. On each day, he randomly picks a route and keeps track of whether he's late or not. He does a 40-day trial, and his notes look like below. So this 40 is key here, because we are going to be calculating out of the 40 days for each of these spots in the frequency table. So, route A, late. He was late 4 times out of the 40-day trial. So 4 out of 40 is 0.1. Route B, late, was 3 out of 40, which is 0.075. We've already figured out 4 out of 40, and that's 0.1. For not late, that was 10 out of 40, which we know is 1/4 or 0.25. Route B, not late, is 7 out of 40, which is 0.175. And 12 out of 40 is 3/10. So if we total these up, 0.1 plus 0.1 plus 0.075 is 0.275, which means that this plus not late should equal 1. 1 minus 0.275 is 0.725, which is also what we get when we add up these 3, as we should. And then adding across, we get following values, which tells us that 35% of the time he used route A, 25% of the time he used route B, and then route C is 0.1 plus 0.3, or 0.4, 40% of the time. Now to find the probabilities, find the probability of being late while using route A. He was late 10% of his days, and he used route A 35% of the time. So we can do 0.1 divided by 0.35, and that's going to get us an approximate 0.2857. Route B, he was late a relative frequency of 0.075. Divide that by 0.25, and we're going to get 0.3. Being late using route C, 0.1 out of 0.4, which is 0.25. So we can see that if he wants to be on time, then he should probably be using route C, because that was the lowest frequency of being late. And he should probably avoid route B when possible. Alright, so that's the lesson for today. I'll see you in class.